Hi! As promised, I'm going to do a side-by-side comparison between the Hantek 2D72 and the OWON HDS272S in this video. Just a quick refresher, the Hantek 2D72 and the OWON HDS272S are both 3-in-1 devices that contain a digital oscilloscope, a multimeter, and an arbitrary waveform generator. I did a few detailed review and teardown videos for each of them over the last couple of months, and for those who have not seen those videos, I'd recommend you watch those videos first so that you can relate to the comparisons I'm doing in this video. As you know, the Hantek 2D72 and the OWON HDS272S are competing directly against each other, so naturally we wanted to see which one offers the better bang for the buck. And my goal is for you to be able to decide which one is more suitable for your needs after watching this video. Currently, you can get either one of these from Banggood, and they are priced very similarly. At the moment, the Hantek 2D72 can be had for just under $170, and the OWON HDS272S is on sale for just above $180. The HDS272S is slightly more expensive, but the specs for the OWON is better compared to the Hantek 2D72 in almost every way. I printed out this chart so we can see exactly how the specs compare with each other, at least on paper. Since the OWON is generally better spec'd, I only highlighted items where the Hantek 2D72 are doing better. The first thing you will see is that the spec'd oscilloscope bandwidth both are at 70 MHz, and the sample rate are also spec'd similarly. They are at 250 megasamples per second for a single channel and 125 megasamples per second for dual channel operation. The refresh rate is not specified for the Hantek 2D72, but is specified at 10,000 waveforms per second, which is actually very good for the OWON. And if you look at the LCD, the included LCD for the 2D72 is a 2.8-inch one, and the OWON one is actually slightly larger at 3.5 inch. Both of these support a resolution of 320 by 240. The remaining two categories for the oscilloscope actually is spec'd slightly better for the 2D72, as you can see that the low frequency response goes below 10 Hz, whereas the OWON goes slightly above 10 Hz. Now, I don't think there's any material differences here, but nevertheless, on paper at least, the Hantek 2D72 looks a little bit better. And also for the trigger accuracy, you can see that the trigger accuracy level for the Hantek is at 0.2 division, whereas for the OWON, it is at 0.3 division, so it's slightly worse than Hantek. Now, the OWON does come with a probe test signal, whereas the Hantek does not. And now let's take a look at the multimeter ratings here. For the multimeter, there's really not a whole lot of comparison going on, as these two are totally different class multimeters. For instance, the 2D72 is a Cat2 rated 4,000 counts non-true RMS meter, whereas the OWON is a Cat3 rated 20,000 counts true RMS meter. You will see that the OWON compared to the Hantek is pretty much better in every single way here. So for the AC and DC voltage measurement, you will see that the bandwidth for the Hantek is 40 to 400 Hz, whereas for the OWON is 40 all the way up to 1000 Hz. And the maximum voltage can be measured is rated slightly higher, which is not a surprise because the OWON is a Cat3 meter. And for the current measurement mode, if you look at it, the OWON also is spec'd a lot better than the Hantek, which is not surprising given its higher counts. For the 10 amp measurement range, there is a key difference between these two meters. For the Hantek, it is not fused, whereas for the OWON, it is properly fused. And for the resistance capacitance measurement mode, the OWON also does a lot better than the Hantek 2D72, which is somewhat to be expected given that it has a much capable DMM chipset. But if you look at the resistance measurement range here, we are topped at 40 megohm for the 2D72, whereas for the OWON, we can measure up to 1 gigaohms. Now, for capacitance, actually, neither of these are great. You can see that for 2D72, the maximum measurable capacitance is about 100 microfarad, whereas for the OWON is about 2000 microfarad. Now in terms of the diode measurement mode for the Hantek, the output voltage is slightly lower than the output voltage for the OWON. For the OWON is 0 to 2 volts, whereas the Hantek is 0 to 1 volt. Now onto the arbitrary waveform generator. If you take a look at here, you will see that the key difference between these two are the resolution of the DAC. So for the Hantek 2D72, they're using a 12-bit DAC, whereas for the OWON, they're using a 14-bit DAC. So that clearly is an upgrade compared to the Hantek 2D72. And associated benefit is also the longer sample depth. If you take a look at the OWON, it's specified at the 8K sample, whereas for the Hantek 2D72, the waveform depth is only at 512 samples. And because of the DAC difference, we also see that in the frequency resolution, for the OWON is actually 10 times better than the Hantek. Now, of course, the Hantek 2D72 does have some advantage in terms of its arbitrary waveform generator here. So if you look at the highlighted items here, the square wave output is specified at up to 10 megahertz, whereas the OWON, it is only going up to 5 megahertz. So, it depends on what your application is, that could be significant. And for the sampling rate, also, the 2D72 is specified at 250 megasamples per second. Actually, that is extremely fast. As I mentioned earlier, that is actually faster than the 962E from UNIT. But for the OWON, the maximum sample rate is at 125 megasamples per second, which is only half of the sampling rate for the 2D72. Of course, all these actual performance for the OWON HDS272S doesn't come for free, as you can see that in the power consumption here. For the Hantek, we're consuming less than 2.5 watts, whereas for the OWON, it almost doubled that. And the battery capacity on the Hantek is actually slightly better than the OWON. So given this, I'd expect the battery in the 2D72 lasts significantly longer than the OWON HDS272S. Dimension-wise, these two units are almost exactly the same size, with the Hantek 2D72 being ever so slightly larger than the OWON HDS272S. And if you hold these two devices in your hand, you will feel that the Hantek feels a little bit sturdier than the OWON, as the Hantek does have a rubberized holster on the outside, and you can remove that, whereas the OWON, everything is built in. And it is soft material on the outside, but it does not feel as sturdy as the Hantek. The first thing I want to do comparison on are the power consumptions of these meters. And to test that, I'm setting the Emerald power supply back there at 4.2 volts output. So right now what you're seeing here is measuring the standby current of this Hantek 2D72. As you can see, it is reading at 1.3 milliamp. And usually you want your standby current to be as small as possible. And at 1.3 milliamp, it is certainly not that small. For the Hantek 2D72, you have two of these 2.6 amp hour batteries. And doing some back of the envelope calculation, you will see that it takes roughly 4,000 hours to fully discharge a fully charged battery. And that translates into 166 days, which is not that great. It's just shy of half a year. So just something to keep in mind. If you do intend to store this scope for a long period of time before using, you might want to double check the battery situation before using it. And now let me power it on. So for that, I'm going to change it to the amp mode. And I'm going to switch it to the amp range because the current draw is significantly higher. And one thing interesting is whenever you disconnect the battery and reconnect the battery, the meter actually automatically powers on instead of staying in the off mode. That's just something to remember. And you can see that in the oscilloscope mode, we're drawing about 310 milliamps. So that translates into about 16 hours, actually almost 17 hours of continuous work time using this 2D72. And now actually I just pressed a few buttons and I noticed that even when I go back to the oscilloscope mode, even though everything else stayed the same, the current increased to about 340 milliamps. So basically that 310 milliamps I think I was measuring before was the absolute minimum current draw for the oscilloscope mode. Now I'm curious to see if I switch to different modes to see if the current draw changes. So for the DMM, and we're drawing actually a little bit more, but it's 350-ish, 360-ish milliamps. And now let's go to AWG. So let me enable the output. And you can see that as soon as we enable the arbitrary waveform generator, the current draw increases to about 450 milliamps. So that is good to know. So now we know that the general current consumption range is between 300 and 450-ish milliamps for this Hantek. So now let's move on to the OWON. Now we're measuring the standby current of the OWON HDS272S, and you can see we're only drawing about 17-18 microamps. That is actually excellent. So now let me change it to the amp range so we can measure the power on current. And let me turn it back over here so we can power it on. And as we expected earlier, the power on current is significantly higher than the 2D72, which right now is at 650 milliamps. And according to the spec sheet, the included battery is actually lower capacity compared to that in the Hantek 2D72. So these are 2200 milliamp hours compared to the 26 milliamp hours. So we did some back of the envelope calculation. That translates into roughly less than 7 hours of continuous use if you are using a fully charged set of batteries in this OWON. And now let me switch to different modes to see if the current consumption changes. So the multimeter mode is roughly the same, a little bit higher. And let's change it to the arbitrary waveform generator mode. Let me enable the arbitrary waveform. And on this OWON, it doesn't appear that the current changes that dramatically in different modes. So we do observe a little bit higher current consumption, but that's just a little bit higher. From the side, you can see these two units are roughly the same size as well. And one thing I mentioned during the review of the Hantek 2D72 is how far recessed that USB-C port is. If you take a closer look, you can probably see the USB-C port, and here is a standard cable. You can see that I can insert it all the way in. Now that is seated correctly. So some viewers commented that this actually design is better because if you accidentally, say, knock down the side of the cable, it will not cause physical damage to the port due to the extra depth. I think there could be some truth to that. Now if you take a look at the same port for the OWON HDS272S, you will see that this port is actually right here, is almost flush with the side of the case here, so there's no problem plugging in any USB-C cables. You also notice that on the Hantek HDS272S, we have the probe compensation output right on the side here, whereas on that Hantek 2D72, we do not have the probe compensation output. Now let's take a quick look at the power on performance of these two meters. And it appears that OWON HDS272S powers on almost instantaneously, whereas for the Hantek 2D72, it took a little bit of time, approximately 2 seconds, to power up. Now let's take a look at the powering off. And it appears now is the opposite. So for the Hantek, it powered off immediately, whereas for the OWON, I did have to hold the power button for about 2 seconds for it to power off. So the performance here are quite comparable. And the OWON has some advantage here with this fast power on performance. And now let's take a quick look at the subjective update rate that we can observe between these two oscilloscopes. And for that, I connected the inputs of these oscilloscope channel 1 together, and I'm going to hook up a very noisy power supply. And right now the power supply is powered off, but you can see that the update rate on these two scopes are drastically different, with the HDS272S updating a lot faster than the Hantek 2D72. The setting of these two scopes right now are identical. You can see that the channel 1 is set at 1 volt per division, here is 1 volt per division, and the time base is set at 1 microsecond, and here is also 1 microsecond. And if I just turn on the power supply, you will see both of these baselines going to jump to the voltage reading. And you can see that they jump about the same way because these settings are the same, but the detected waveforms are different. With the HDS272S, we can see more rapid changes on this scope. And for the next test, I'm going to compare the acquisition speed of these two scopes and also try to see the behavior of the scope when we're approaching the bandwidth limit. Right now, I'm inputting a 50 MHz signal 0 dBm from my HP8642B signal generator, and the input of these channels are connected, so they're both showing the same signal. Now let me automatically acquire the signal. And you can see for the Hantek, it took about 5 seconds to acquire that signal. Let's try the same for the OWON. It only took about 1.5 seconds, even though we mentioned earlier in the review that for whatever reason, the amplitude does not get automatically set correctly on OWON a lot of the times. So let me manually set the OWON up. So now these two signals are identical. The first thing you will notice is that the signal on the Hantek is a little bit of unstable. It wobbles a little bit back and forth, but the trace itself is very thin and crisp. Whereas on OWON, the whole signal appears to be very stable, but I suspect it's because of its fast update rate that the signal does ever so slightly shift back and forth, so that translates into this thickened waveform plot, as you can see on the screen here. And now I just turned on the on-screen measurement as well, so you can see what is being measured. Right now, the input signal is sitting at 50 MHz. So what I'm going to do is gradually increase the input signal, and let's observe what the waveform looks like on each of these oscilloscopes. And also let's see at what point we are not able to measure that input signal anymore. So let's turn on to, let's see, 60 MHz, and no problem at all, even though on this one the amplitude dropped quite a bit. Now, I would not worry too much about that because right now we're essentially a 50 ohm terminated system here, so that could add some of these discrepancies we see here. And let's just concentrate on that signal itself. So let's go to 70. That's 70 MHz, and we have no problem measuring that here, no problem measuring it here. So now let's keep increasing. Let's change it to 80 MHz. And you can see both of the scopes have no problem displaying the waveform and also measuring the waveform itself. Now let's do 85. And you can see that on the OWON, which we also observed that during our review, the maximum frequency you can measure is actually at 80 MHz. So I believe that is something that limited by the hardware itself. Whereas for the Hantek, we can still measure that waveform at 85 MHz right now. So let's keep increasing. 90 MHz, no problem. And now it's 100 MHz. As you can see, the OWON actually not only does worse in terms of the measured signal, we have a lot of distortions, and we are also not able to measure it. So let's auto-acquire on the Hantek and see what we got. So you can see that we are able to acquire the signal. Also, we're able to measure that signal. And that in my opinion, actually the display here is a little bit better than the OWON, although from the wobbling of the signal essentially expands to the same shape, but at any given moment you can see the signal more clearly here. So let me increase it to 110. You can see we still can measure it with no problem, although the waveform significantly get distorted because we have essentially very limited sampling rate here, and we're approaching that 2 samples per waveform limit already. So let's do 120. And obviously this is beyond what can be actually properly measured by the oscilloscope, but nevertheless you can see we still have that hardware counter frequency relatively in the same accurate range, whereas for the OWON that just totally dropped out a long time ago. Next, let's compare how these scopes handle the modulated signals. For that, I'm putting in a 1 MHz carrier with a 100 kHz amplitude modulated signal. On top of that, the modulation depth is at 100%. So now let me automatically acquire the signal. And now let's adjust the time base so we can see the signal a little bit better. And let's try to change the trigger level. So as you can see, we're struggling triggering on this signal, but this is probably as stable as we can get on the Hantek. Of course, we can change the time base a little bit. So now let's do the same thing on the OWON. So let's see, time base. And you can see we are actually getting some artifacts, depends on the time base that we're currently at. So let's first change the trigger level so that we can make sure we can trigger that signal very, very cleanly. And we can change the time base again. And you can see that the signal is traced very cleanly and there's no jitter back and forth. Now we're looking at a frequency modulated signal. This time is a 1 MHz carrier frequency with a modulation frequency of 30 kHz. And the frequency deviation is 100 kHz. So again, let me automatically acquire the signal. And again, as you can see how fast the OWON does its job, whereas the Hantek, it is still working. Again, both of the scopes acquire signal with no problem, but notice that Hantek actually automatically set the time base to 200 nanoseconds, whereas the OWON is at 500 nanoseconds. So let me increase the time base on the Hantek to match that on OWON. You'll notice that the displayed signals look slightly different. This is because the Hantek has a slower update rate, whereas the OWON has much faster update rate. Nevertheless, both of the scopes are able to display this frequency modulated signal, although I prefer the OWON display a lot better, as you can clearly see the frequency modulation on top of the carrier. Whereas on the Hantek you can see that the signal is moving back and forth. That's due to the slow refresh rate, but nevertheless you get a sense that the signal is being frequency modulated. Of course, the OWON has a much larger display, 3.5 versus 2.8. That makes it a lot easier to see the waveforms on the OWON. And now let's compare the XY mode performance of these two oscilloscopes. And for that I'm using my Unity UTG962E to generate two sinusoidals, putting into both channel 1 and channel 2 simultaneously, so that I can generate a Lissajous pattern. Right now the input signal from both channels are 5 kHz at 3 volts peak to peak. And I'm going to change the frequency of channel 1 so we can see the patterns are changing. You can see that the update rate of the Hantek is not that great, as at 5 kHz the frequency is fast enough so we shouldn't see this kind of animated effect, and we should just see the pattern changing instantaneously. But that's clearly not what we see and we can change the patterns here. But nevertheless, it represents that Lissajous pattern with no problems. And this certainly is a better digital oscilloscope compared to a lot of the ones I have seen where they are unable to generate any meaningful Lissajous pattern when you are using the XY mode. So this clearly is not bad at all. So now let's take a look at the similar patterns on the OWON HDS272S. And right now the signal from the 962E goes directly into the OWON HDS272S. As you can see the pattern right now being generated. Again, I'm going to change the frequency of channel 1, and you see that how instantaneous that pattern changes. And this is actually almost as good as any analog oscilloscope, and is certainly a lot better than most of the digital scopes I see in this price range and even the more expensive ones. So this implementation is actually fantastic. And just to show you how impressive this really is, right now I have the frequency set up to be 5 MHz on each of the output channels. So you can see that we still have a very decent shape there, and even I adjust the output frequency, you can still see the Lissajous pattern very well captured on the scope. So this is really amazing. And the same cannot be said for the Hantek 2D72 for the same 5 MHz signal I'm putting in, and you can see that we cannot capture the actual shape just because the sampling is not fast enough. Next, I want to take a quick look at the multimeter functionality of these two meters. I'm not going to spend too much time comparing these meters as these are different class meters. The OWON is a 20,000 counts multimeter, whereas the Hantek is a 4,000 counts multimeter. So any direct comparisons would be pretty much meaningless. But I do want to point out a few things that I think the OWON implemented better than on the Hantek. One thing is the update rate. You can see that the readings on the OWON updates about 3 times per second, whereas on the Hantek it updates around 2 times per second. So clearly, the faster the update rate, the better it is. One area I think the OWON did better is the inclusion of this rel button. A lot of the times when you are measuring, for instance, you are measuring the resistance or capacitance for that matter, if you wanted to rel out the actual readings, for this Hantek, there's no way for you to rel out that residual reading. Whereas for the OWON, you can just press the button. In fact, not just the capacitance range, but also any range that you want to measure. For example, the ohm range, you can also, even though it's very slow, but you can rel out the readings, and then when you are measuring a resistor, it will show you the true reading of that resistor. Although the OWON meter has a much higher count than the Hantek, the performance is not that great, especially in the ohm measurement. You can see that it's really slow. If I short the leads, it takes a good 4 seconds for the readings to register. Whereas for the Hantek, it's pretty normal, at least compared to a regular multimeter here. So that is something just to notice, that you wouldn't want to use it for your everyday measurement. And forgot to mention that the OWON is a true RMS meter, whereas the Hantek is not. And let's take a look at continuity. So for the continuity mode, the OWON is latched, whereas the Hantek is not. So it is a little bit scratchy, as you can see here. But again, in a pinch, you can use either meter to do all sorts of measurements as you would with the traditional multimeter with no problem. And the last thing I want to comment on are these input jacks. If you take a look at the OWON meter here, and I can pretty much use any standard input leads into these jacks. So for example, this one is the one from Unity, and I can plug it in with no problem. Whereas for the Hantek, actually because it has a solid end, so for that, I actually cannot put in this Unity leads in all the way. You can see that. So that's just something to keep in mind. Not that it would matter most of the time. Now let's move on to the arbitrary waveform generator. And if you recall from our spec discussion a little bit earlier that both of these units are capable of generating roughly up to 25 MHz of signal, and they have pretty comparable specs here as well. Of course, the OWON HDS272S has a much better resolution DAC at 14 bits versus a 12-bit that we had in the 2D72, and it supports more sample points per waveform. From a user interface perspective, that the OWON comes a little bit more modern, whereas for the Hantek, it's a little bit of old-fashioned. But the Hantek one, I do like one thing is you double-click on a specific parameter, you can use a keypad to input exactly what you want. Whereas for the OWON, you have to use these kind of arrow buttons to set each individual digit and use the up and down to dial in the specific number you're looking for. I think either way it works, but I prefer the Hantek way of more direct input. In terms of the maximum output range, these two meters are actually very comparable. Now, it might cause some confusion as how these parameters are specified. If you take a look at Hantek, it says right now the amplitude is 2.5 volts, whereas right now, out of default, the HDS272S is showing as an amplitude of 5 volts peak to peak. Now, the 2.5 volts is really from the 0 DC line to the top of the signal here. So these two signals right now are actually identical. So I'll show you that. You can see that from the scope behind. And if I plug this in, you can see this is the one from Hantek, and the second signal is from the OWON. So these are indeed identical signals. As I mentioned in the Hantek 2D72 review, that the square wave generation has some issues. As you can see that on the scope back there, that at 20 MHz, the waveform actually does not maintain the same width. So not sure why it's oscillating every half a second. And I do hope that is a firmware issue that can be addressed by Hantek. But the maximum frequency for the Hantek is at 10 MHz, whereas OWON is at 5 MHz. So let's take a look at the waveform generated by OWON. So right now we're outputting a 5 MHz signal from OWON, and you can see that the signal is very stable and very clean. Now a quick look at the output spectral purity. For that, I'm outputting a 25 MHz signal. Right now it's from the Hantek 2D72 to the spectral analyzer. And the analyzer currently is set to sweep between 10 MHz and 50 MHz. And let me zoom into the spectral analyzer so you can see it a little bit better. And you can see that the signal from the Hantek is relatively clean. We do have some spurious here and there and some of the harmonics at the higher orders. But besides that, the general signal is pretty clean. So let's swap this out to our OWON signal, and we can see what that signal looks like. Again, OWON is set up in pretty much the same way, outputting a 25 MHz signal. And right now you can see though, we do have a more pronounced spurious signals here. So clearly those are just some of the artifacts from the synthesizer, but regardless, the signal output are pretty comparable. So that is from the signal sitting at 5 volts peak to peak output amplitude. If I reduce that amplitude, you'll see that the distortion also is significantly reduced. Right now I'm sitting at 1 volts peak to peak, and the only thing you can see are these harmonics, and the distortions are gone. So this tells me that the output amp of the OWON HDS272S may not be as good as the one in the Hantek 2D72. And just for comparison, let me switch back to the Hantek. So now we're looking at the Hantek output signal. Currently the amplitude is also sitting at 5 volts peak to peak, and let me start reducing that amplitude. And we'll see that the signal gets a lot cleaner. In fact, when we are at the same, let me just see if I can go to 1 volts peak to peak. So let me just bear with me here. Here at 1 volt peak to peak, actually all the spurious signal and the harmonics are gone. So the output amp and the filtering circuitry is doing a great job in that 2D72. So in conclusion, except for a few areas, the OWON HDS272S is superior in almost every way compared to the Hantek 2D72. This is especially true for the oscilloscope mode. The waveform refresh rate on the OWON HDS272S is just phenomenal, and it is likely one of the best in the entry-level oscilloscope market. And the XY mode performance is also one of the best I have seen in a digital oscilloscope, even including ones that cost several times more. Also, the waveform stability is much better on the OWON compared to that on the Hantek. For the multimeter functionality, there isn't really too much comparison between these two devices, as the HDS272S is a 20,000 counts true RMS multimeter, whereas the Hantek 2D72 only offers 4,000 counts, and is not true RMS. And the accuracy for OWON is also much better compared to the Hantek as well, but neither of these meters are speedy by any means. In my opinion though, the multimeter performance shouldn't be weighed as much towards your purchasing decision, as you probably wouldn't use this device solely as your only multimeter on a day-to-day basis. And to be honest, either of these multimeters would get you by just fine in a pinch. For more serious measurement, you will probably want to use a dedicated multimeter anyway. Finally, onto the arbitrary waveform generator functionality. This is where your decision could be swayed one way or the other depending on your needs. On paper, the OWON is mostly superior compared to the Hantek, as it has better resolution, 14-bit versus 12-bit stack, longer waveform depth, 8,000 sample points versus 512 samples, and a finer frequency resolution given the better DAC used. But the lack of a computer software for creating your own arbitrary waveform could be a deal breaker for folks that need specific waveform that is not included already on the scope. And the included PCA software is much better for the Hantek than the OWON. So if you need to create your own arbitrary waveforms, you can only do that with the Hantek 2D72 at the moment. I'm hoping OWON would release a software update that allows the creation of arbitrary waveforms, as the hardware is more than capable. The Hantek 2D72 is also less power hungry compared to the OWON HDS272S, and the estimated runtime per charge for the Hantek is 2 or 3 times better compared to the OWON, so this could be important if you are mainly using the device in the field. So I hope this video gives you enough information for you to decide which one better suits your need. I hope you enjoyed the video, and if you liked the video, please remember to give it a big thumbs up and remember to share and subscribe to the channel so you won't miss out more videos like this in the future. I will catch up with you next time.